it's not something you need to go to the Galapagos for or to study fossils for to observe. It's a very mundane process that goes on all around us.
You are listening to Urban Wildlife Podcast.
Hey, podcast listeners. For months since we heard of it, we've been waiting for Menno Schilthuizen's book, When Darwin Comes to Town, How the Urban Jungle Drives Evolution, to come out. Now it's finally out, and I got a chance to interview Menno for our podcast. We hope you like the interview. Menno will be talking at the Academy of Natural Sciences of Philadelphia, Drexel University, Town Square series on April 11th. The program gets going at 5:30 and goes till 8:30. If you're hearing this and you're in the Philadelphia area before April 11th, then head on out and see him. If you're listening to this after that date, or if you're not in Philadelphia, I still think it's a great interview, and the book is totally worth checking out or buying or downloading or however you read books. It's full of really fascinating examples of evolution taking place in cities and other forms of adaptation by animals and plants to city living, to city landscapes. And also some interesting discussion about what makes evolution in urban settings possibly different than evolution in more, quote, natural settings. Might not agree with everything that Menno proposes in terms of management or conservation recommendations for cities, but either way, it's a great starting point for conversation. Again, just some fascinating examples of what evolution looks like in urban settings. Thanks. Of course, if you like our podcast, please rate it highly on your podcast listening app of choice. If you want to get a hold of us, like if you've got a book coming out about urban wildlife or urban nature in some way, please pop us an email at urbanwildlifecast@gmail.com. Send us something on Twitter at urbwildlifecast, and we'll be happy to talk to you and hopefully put something on the podcast.
My name is Menno Schilthuizen, and I'm a professor of evolutionary biology at Leiden University in the Netherlands, and also a research scientist at the Naturalis Biodiversity Center, also in Leiden.
Could you talk a little bit about house crows? Where do they live?
Yes.
How'd they get there?
House crows are a species of tropical crows, which originally occurred in sort of South Asia, in India, Sri Lanka, Bangladesh, Burma, and it seems that over the past few centuries they have given up their natural niche and have started living with people instead. And in fact, you don't find them in the wild anymore. You only find them in cities. In their native range, but also in tropical cities all over the world. You find them in Singapore, you'll find them in various cities in Africa, in the Middle East. And even until recently, there was a population occurring in my home country, in the Netherlands, in the city of Rotterdam, which was founded by a few, probably a pair of birds that had hitched a ride on a ship, on a cargo ship, probably from who knows where. It could have been Singapore or some other big Asian port, and somehow managed to survive and actually thrive in the Netherlands, which is almost 50 degrees latitude north of where they normally occur.
And so you said up until recently, what happened to them?
Yes, they. This pair multiplied into a colony of about 40, 50 individuals, which were happily living around a soccer field and building their nests from colored nylon string that they pilfered from shipping rope in the port, and they were eating fish and chip scraps from the snack bar on the corner. But then, and everybody liked them. They were getting visits from local bird watchers because it's just a new species, too many of them to watch. But then the local authorities got wind of it, and it's a species that is in some cities in the tropics is considered a nuisance. It's a pest. Singapore, for example, there were hundreds of thousands of them, and they were eating garbage, and people didn't like them, so they started culling them. And the local authorities in the Netherlands were afraid that the same might happen to these birds in the Netherlands, so they decided that this invasion should be nipped in the bud. So they hired a professional hunter to kill all all the crows, which was harder than they thought. First of all, because the local people didn't like it. They were actually quite fond of these crows, so they set up a committee to protect them. And also, the crows are very clever, so that it took this hunter many years actually to finally shoot the last one, because they are very good at evading him as soon as they started recognizing him.
What makes a species like a house crow? What distinguishes them, and what makes them able to to slip into cities like this?
Yeah, it's hard to give a general answer to that. It depends, I think, on the type of animal or plant that you're talking about. Crows are very good at living with people. They are animals that are normally from sort of dynamic environments. I mean, in the wild, you will often find crows in habitats that are already quite unstable, which change a lot, like floodplains and estuaries and places like that. So they are probably already predisposed to deal with a constantly changing environment and to be very good at finding new opportunities. And that's, of course, a characteristic that is very useful for an urban species. And I think in many birds that's something that you do see, and probably mammals too, that the ones that are good at becoming an urban species, are successful in cities, are animals that are originally from that sort of habitat. But there's many other characteristics that can help. For example, species that originally live in very rocky environments, on cliffs, like the rock pigeon, which is now the city pigeon, like the peregrine falcon, which also is thriving in many cities. Those are species of birds that originally live in very rocky places with a lot of cliffs, which to them resembles perfectly the landscape we've created in cities with tall buildings and ledges on which they can perch and nest. So those are a few characteristics, but for every type of animal you can list a number of conditions that seem to predispose species to become urban species.
So once, let's say, something like a pigeon, the rock pigeon, ends up finding cities as good habitat, what are some examples of how you see pigeons and other species apparently evolving to be even better suited to urban habitats?
Yeah, exactly, because the predisposition is just the first step. That will probably help them to gain a foothold in the urban environment. But after that, it seems that in most species there are additional evolutionary changes that take place in the city populations, which make them better and better at dealing with the conditions that we humans throw at them. So in city pigeons, for example, it's been shown by French researchers that in cities the pigeons have darker plumage. So in pigeons you find several different types of feather color. They can be light gray, they can be dark gray. In cities, you find the dark gray ones much more frequently than outside of cities. And it turns out that this has to do with the fact that they can use their feathers to get rid of pollution by heavy metals. So lead and zinc, which they ingest through their food and their water in city environment. There's quite a lot of lead and zinc pollution in cities from zinc is being used as coating on lampposts, for example. It's constantly flaking off, and that's how they ingest it, but it's not good for them. And the darker ones are better at surviving because there's more melanin, the pigment that makes these feathers dark, in their plumage, and melanin binds to these heavy metal. So though they instead of keeping it in their system, they can detox themselves by putting these lead and zinc ions in their feathers, and when the feathers shed, then they can do the same thing again with the new feather that they grow. So that's one example of a process of urban evolution on top of this predisposition that they already had.
You've also in the book talked a little bit about examples of species that might not have actually been evolving but have adapted behavior. You talk about some of, let's say, the songbird song responses.
songbirds are a very good example of animals that change their acoustics. So they change their songs, especially the frequency of the songs at which they sing. In cities, there's a lot of background noise from traffic, and birds which have a low frequency song will have trouble being heard by their conspecifics in such a noisy environment. So what you see in cities is that they start singing at a higher pitch, and then the frequency of the song rises above the background noise. So they can continue to communicate with each other. It's not always clear whether that is simply a matter of learning. In many birds, for example, they have quite a big repertoire. They have low-pitched songs and high-pitched songs, and that they simply learn that they have more success when they pick the high-pitched ones, and then that changes then their repertoire over time. That would be a learning effect, a sort of an adaptation in what they do without any genetic change. But there's also some examples of birds where actually the song frequency seems to be evolving, where it's really a genetically determined, the pitch at which they sing is genetically determined, and there you see that this species is changing in a sort of non-reversible way, the pitch at which they sing, and we see this, for example, in birds which are not songbirds but which still call, and I think, for example, pigeons actually, and woodpeckers. There are several groups of birds which of course also produce sounds, but they're not songbirds. And for them, the pitch at which they call is much more strongly genetically determined. And in those species, you also see that the pitch changes. So there, it might actually be a genetic change rather than simply learning to sing at a higher pitch.
Is this anything particularly new? I mean, I know that urbanization, to the extent that we're seeing it today, is new. Mm-hmm. But humans have been shaping landscapes for, I don't know, tens of thousands of years, looking at, I guess, ways species might have adapted to agricultural landscapes. Mm-hmm. I don't know, thinking of like house sparrows or something like that.
Yeah.
Is urban evolution distinctive in some way, or is it just like another phase of life adapting to human landscape changes?
Yeah, I think you're right that in some sense urban evolution is no different from any of the other cases of rapid evolution in response to humans changing the environments that we've seen in the past. Although often people don't realize that evolution is involved, but many agricultural pests, for example, that have appeared over the centuries probably also involve evolution. That is, are often wild insects that hop onto a crop that we humans plant and then become a pest. And often this process of becoming a pest involves genetic changes that make these insects exploit this crop better than their original food plant. So that's also a case of evolution that you could consider urban evolution, or at least what I call high-rec, human-induced rapid evolutionary change, which is any kind of evolutionary adaptation to a change in the environment that is caused by humans. But I do think that there is something special about specifically urban evolution, in that the whole system of the urban ecosystem evolving seems to be running by different rules than is the case in natural environments. And that has to do with two things. First, the fact that it's a sort of a global phenomenon, which is often not the case in natural systems. The fact that cities are connected globally, both in terms of the species that are being transported between cities by humans and by traffic and by commutation, are being homogenized, but also the conditions to which animals and plants in cities adapt are being homogenized. As soon as a new innovation takes place, let's say LED lights in street lighting, which have a much broader spectrum than the street lights we've seen in the past few decades. Presumably, a lot of nocturnal animals and plants need to adapt to that new spectrum of artificial light at night, and this innovation spreads via technology all over the world in a very short time. So this system of globally connected urban ecosystems is something that is really unique in evolution. Now, all the previous cases of evolution that we've seen would not have been so globally synchronized as they can be in an urban context. So I think that makes urban evolution quite unusual as a process.
What do you think we should do about it? Is this something just to observe? Is it something to fight? Is it something to foster? What do you think?
I think it's definitely something to be interested in and to be wanting to monitor and to observe, simply because it's in a sort of an educational and environmental awareness sense. I think it can be very instructive to realize that such a profound process as evolution is actually a very mundane law of nature that you can watch taking place all around you, even in your backyard. And it's also something that citizen science can play a big role in, I think, because people are concentrated by definition in cities. That's also where you can find the largest concentrations of observers who can make pictures of animals and plants, and we can use those photographs to document the changes in the appearance of animals and plants in cities. So I really have a dream that we could build a citizen science urban evolution observatory made up of people who are uploading pictures of animals and plants in cities all over the world. And also, I think if cities continue to grow and this urban habitat becomes a more and more systematic part of life on Earth, and definitely it will be the kind of environment that most people will be seeing. In the future, most people on Earth will not be traveling to pristine habitats, but most of the wildlife they will see will be in the cities where they live. A lot of the ecosystems that we are part of will be urban ecosystems. So the evolution of those systems is going to be a very important part of the world's ecosystems, of which humans play a very fundamental part. So if we can observe, understand, and maybe even harness this process of urban evolution, and by harnessing I mean we could design cities in such a way that urban evolution in urban animals and plants is stimulated, we can actually make use of the process to build maybe a more livable environment for the future. I think one of the things you could do is be aware of the fact that the city is already full of species that are adapted to urban conditions. So if you're building or designing a new green area or a green wall or a green roof, it might be wiser not to stock those places with plants that you pick out of a catalog of a garden center. You could simply provide the soil and wait for these vegetations to develop naturally out of the pre-adapted plants and animals that are already living in the city and that are more than happy to colonize new bits of available soil. So that's one way to do that. And another thing would be to maybe reconsider the idea that green areas in cities should always be connected. This is a has of course been a trend to make corridors between parks and patches of green vegetation in the city, because that's what we've learned from conservation outside of cities, that connecting all these fragments of vegetation is good, and it can be very good for large animals which need more space to survive, and they can get more space if you connect a lot of small pieces. But in cities, probably local adaptation is maybe even more important than outside of cities. The fact that every city park has its own ecological signature, its own special local conditions that the animals and plants that are living in that park need to adapt to. And if you connect those parks, then it could be that you're creating sort of an effect of swamping of genes that are locally suited for the local condition by genes that come in from other parks, and which may prevent that process of local adaptation. So I think it might, for many smaller animals and also plants, it might actually be good not to connect those parks, but actually allow the species in those parks or in those pockets of greenery to adapt perfectly to the local conditions, rather than connecting them by making corridors between them. So those are two examples of ways that I could see to stimulate this process of urban evolution.
What do you do about species that lived in a place prior to there being a city, but weren't, let's say, weren't predisposed to be able to live in the city in the first place? So how do you balance sort of broader conservation goals for the place that a city has grown up in with what might be sort of city-specific conservation goals?
Yeah, that's a good point. You do of course have this sort of generalized urban wildlife that you see in cities everywhere, and which is also homogenized between cities. But at the same time, cities can also be places where very local species are surviving, which are not maybe the best urban species, but which you would also like to preserve in a city context. And often cities are the only places where these species can survive if outside of the city there's very intensive agriculture. So in those cases, I think sometimes individual species can be important, although I think real species-focused conservation still tends to pick out a few charismatic species which are not necessarily keystone species in the food web. We conserve them because we like them. So there may be lots of species that we don't know about, for which the same applies. So it's not always sure whether you should focus on producing a food web in the city that has the right functional components in it, that runs smoothly, or whether you should focus on individual species that have high conservation value. But I think you can probably do both. There are, if you have good monitoring of where species are and how they're distributed in the city, then you can actually pinpoint bits of habitat in cities where these local endemic species occur, which you could give special protection, and maybe actually by preventing those corridors that I talked about earlier, you can actually maintain a species in a pocket of habitat, even though it would have been outcompeted by a similar species that would have been introduced if you had connected it with other patches in the city. So I guess some sort of conservation strategy in which you identify fragments of vegetation in a city that have these interesting local species, and other ones which have a more generalized urban wildlife. And if you make sure that those do not get in too much contact with each other, you can have your cake and eat it.
Thanks. So one last question I should have asked you before. How did you end up writing a book about this topic?
I like to see myself as sort of an all-round evolutionary biologist. I'm interested in anything that has to do with ecology and evolution, and also in my research, I actually have a rather short attention span. I spent a few years on one topic and then I moved to something else. And on top of that, I have this habit of writing books for the general public, which do not necessarily need to have a very strong connection with my own research. It's just that I know about the field, so I like to explain it to a more general audience. And that's certainly true in this case, although I do some research on urban evolution myself, on snails mostly. But the main reason I think to write this book is that I myself am fascinated by these very observable, close to home examples of rapid evolutionary change, and I use examples like that a lot in my teaching and in lectures I give to the general public. And I think it's a very evocative way of introducing people with the process of evolution and making them realize that it's not something you need to go to the Galapagos for or to study fossils for to observe. It's a very mundane process that goes on all around us, and by placing that story in the context of something so familiar to us as the cities we live in, you bring it literally very close to home.
Hey, podcast listeners, we hope you liked that interview with Menno Schilthuizen. Again, if you're in the Philadelphia area on April 11th, please come check them out at the Academy of Natural Sciences of Philadelphia of Drexel University, their Town Square series from 5:30 to 8:30. If you're not in Philadelphia or you're hearing this after that date, don't worry, the book is still amazing. Please check it out, buy it, download it, however you want to consume the book. And of course, if you want to get in touch with us about your book or anything else you want to get in touch with us about, you can try us at UrbWildlifeCast on Twitter or send us an email at urbanwildlifecast@gmail.com. And here we're going to leave you with a little extra, a conversation we had with someone at a recent BioPhilly seminar. We were talking to some people about their urban wildlife experiences just before Tony talked on a panel about urban wildlife and, broadly speaking, how architects and designers and engineers can work in nature at putting together landscapes that humans live in. How can we make them great landscapes for nature also?
My name is Elizabeth Glass. Well, when I was a student, I lived 10 years in San Juan and the iguanas. San Juan, Puerto Rico, yeah, the capital of Puerto Rico. And the iguanas, they're kind of an invasive species now, and you can see them like going across the street, even on the highways, getting on the backyards of the houses, everywhere. You can see them everywhere. And people are getting like stressed with them, but at the same time, at least for me, I really like it to see them because yeah, there's another species living with us, and you have to deal with it and integrate them to the nature. So yeah.
Exotic, invasive.